Hi everyone, and welcome to the first official video for AP Calculus. Today we're going to be talking about the idea of a limit, which is going to be the foundation that we look at in this whole first chapter of calculus. So before we jump in here, in terms of our learning targets, which you have in your packet, I just want to point out what we're going to be focusing on today is being able to find the value of a limit by looking at a given graph. So hopefully by the end of this video, that's what we should be able to do, is if I give you a graph and ask you for the value of a limit, you should be able to find that using the graph. So I think it's always kind of good to have in mind what we need to be able to do by the end of the video. So the idea of a limit, all it does is describes the behavior of a function close to a particular value of x. So we're trying to describe what that function is doing close to a particular x value. So it does not necessarily give us the value of the function itself. It's just describing the behavior in that close neighborhood of x. So here's what the notation looks like. And here's what we would say. We would say the limit of f of x as x approaches c is L. And here's really what that's saying. This is specifying an x value, which we can see here in our picture. And when we're looking at a limit, what we want to know is, around this x value, what's our function doing? And we can see here, even though the function itself is undefined at c, we can see that both from the right and the left side, that function is approaching L. And that's why we have here stated that our limit is equal to L. That L, I'm going to make a note here, is just a y value of the function. So it kind of tells us what y value are we trending to as x approaches c. Now, something important here to note is that the actual value of the function at a given x value does not affect the value of the limit. So again here, we know that f of c, I see there's a hole there, so it's not actually defined. However, we still know that that limit as x approaches c is equal to L. So the function value and the limit do not have to be the same value, though at times they will be. Now, when we talk about limits, we're really going to be talking about two types of limits. And the idea is the same, it's just getting a little more specific about which direction we're approaching the x value from. So the first one is our right-sided limit, and this just looks at the behavior of the function as x approaches the given value from the right side. And we indicate that we're coming from the right side by doing this. The limit as x approaches c, and we use that plus sign to mean from the right of f of x. And we would just say the limit of f of x as x approaches c from the right. So let's look at this example. Let's say that our value of c, let's make that 2. So let's say I want to look at the limit as x approaches 2 from the right, and we're going to call our function f of x. Now, if I look at my graph, obviously if this is 2, everything on this side of 2 is from the right. This is to the right side of 2. So if I'm looking at my function and following my function to the right side of 2, if I follow my function really close to 2, that function value that I'm approaching is 8. So that's the value of the limit, because that tells me about what my function is doing really close to 2. Now remember, I just want to keep reminding ourselves, the actual function value, if I were to look at f of 2, the actual function value is 6, and that's okay. The limit and the function value may be different values. That function value actually does not impact the value of the limit itself. So just like we can talk about right-handed limits, we can talk about left-sided limits. And obviously this looks at the behavior of the function as x approaches the given value from the left side. And now we would write the limit as x approaches c from the left of f of x. Notice that whenever we use that limit notation, we have to specify a function. And so in this case, we would say the limit of f of x as x approaches c from the left. So we're going to look at the same graph here, and we're going to use that same c value of 2. So we'll say the limit as x approaches 2 from the left of f of x. Now again, here I have 2, so my left is coming from this side. So if I follow that curve from the left as I approach 2, that function is approaching 6. And so here you can see that actually the left-handed limit in this case is equal to the function value. Okay, so let's go ahead. We've got one more kind of big idea to look at, and then we can look at some actual examples. So the last thing we need to talk about is the idea of a two-sided limit. Okay. So a two-sided limit looks at the behavior of the function as you move towards the x value from both sides. And so here's what's really important. Our two-sided limit only exists if the limit as I approach c from the left is equal to the limit as I approach c from the right. That's the only way I have a two-sided limit. So in other words, a two-sided limit only exists if both one-sided limits approach the same value. So let's look at an example here. Let's look at the limit as x approaches, I'm going to use 1 from the left. So if I look at this graph, and I'm coming from the left of 1, I'm approaching a y value of 4. So I know my one-sided limit is 4. Now, if I look at the right-hand limit, x approaches 1 from the right of f of x. Now, as I'm approaching 1 from the right side, in this case, my y value that I'm approaching is -2. In this case, since my left and right hand side don't agree, we would say that the limit as x approaches 1 of f of x does not exist because the left hand and right hand limit do not equal the same value. So that's what we mean there. Now, we could pick another value, let's say as x approaches 6. I can see pretty clearly here that as I approach from the right, I'm approaching 5. As I approach 6 from the left, I'm approaching a y value of 5. So that would have a two-sided limit. So now we're going to just look through some examples kind of for the rest of this video and make sure we can find those values by looking at a graph. Again, that was our target. Today is just all about looking at graphs and finding the values of the limits. So let's look at number 1 here. This says the limit as I approach 1 from the right. So now if I'm seeing that 1 is here, if I approach from the right, I'm approaching a y value of 1. Remember that limit is always a y value. Now, if I approach 1 from the left, so I'm approaching from here and following the function, I also approach 1. Since my right side and left-sided limit are the same, I know that my two-sided limit is that same value. Let's see. Let's look at the limit as x approaches 2 from the left. Now already I can see that something kind of funny is happening here. So 2 from the left side, my y value is 2. I'm going to move over here. Now 2 from the right side, if I come from the right, I'm approaching 3. So here we have a case where our left-sided and our right-sided limit are not the same. So we know our two-sided limit does not exist. And here's how we explain our answer. Again, the directions tell us to explain why not, and we do that by specifying that our one-sided limits are not equal. So whenever you're asked to explain why a limit does not exist, this is what we're looking for. Just stated that those one-sided limits are not the same. Now, these kind of scaffolded the problems for us. So they had us look first from the right side, then from the left side, and then consider the two-sided limit. So we have to be careful in a problem like number 7 that we consider both one-sided limits before deciding if the two-sided limit exists. So as I approach 3, I can see here as I approach 3 from the right, I have a value of 1. As I approach from the left, it's also a value of 1, so I can say that limit is just 1. At 4, if I approach 4 from the left, I'm approaching a y value of 2, and same from the right here. I'm approaching that y value of 2. Now remember, we said that the function value does not affect the value of the limit, because either way I'm approaching that y value of 2 even though my function isn't actually defined at that point. All right. We're going to do this last group of questions here, and actually we'll save the sketching at the end for the start of class tomorrow. We're going to look at the same thing again. We're still trying to find limits looking at a graph. I just wanted to look at this here because now we've got some vertical asymptotes, so we got some different behavior going on here. So let's look at the first one. This says the limit is x approaches -2 from the left. And so that's going to be interesting because I notice there's a vertical asymptote here at -2, x equals -2. So as I approach -2 from the left, this asymptote is forcing my graph to go to positive infinity. So now we will have some limits that have values of infinity or negative infinity, and that's going to happen because of these vertical asymptotes. Same thing, the limit as x approaches 1 from the right. If I'm coming from the right, again, this is forcing me up to positive infinity. Now, as x approaches 5, here I'm again seeing that vertical asymptote, but here I have to be careful. This is the two-sided limit, so I have to consider both one-sided limits and decide if they're the same. Now, when I look at 5 coming from the left, that's going down to negative infinity. 5 from the right is positive infinity. Since those values are not the same, I know this does not exist because the limit as x approaches 5 from the left of f of x is not equal to the limit as x approaches 5 from the right. Now, this one